PCB traces, along with dielectric materials, form a capacitor, resulting in an unwanted parasitic capacitance, or stray capacitance effect. This effect is prominent in high-frequency boards. Parasitic capacitance can exist between conductors on PCBs, bare boards, assembled boards, and within component packages, especially surface mount devices. The parasitic capacitance is calculated as C equal Q over V, where C is the capacitance in farads, and V is voltage in volts, and Q is the charge in coulombs. Parasitic capacitance is caused by parasitic elements, such as inductors, formed by package leads, long traces, pad to ground, pad to power plane, and pad to trace capacitors. To reduce parasitic capacitance in PCB layout, avoid the parallel routing traces, remove power planes from the vicinity of conductors, use Faraday shield between traces. Other ways to reduce parasitic capacitance are to minimize the number of vias, increase the space between traces using the 2W or 3W rule, use low permittivity dielectric materials, and choose the right layer thickness. Lastly, careful separation of components and wires, guard rings, power and ground planes, shielding between input and output, and properly terminated transmission lines are essential for parasitic capacitance reduction. Unfortunately, it is not possible to completely eliminate parasitic elements, but accurate design and manufacturing decisions can control these parasitics.